Graph the following rational function by finding the horizontal and vertical asymptotes and the x and y intercepts. In order to find the vertical asymptotes for this function, we will need to set the denominator equal to 0 and solve for x. So x squared minus x minus 6 equals 0. If you use your factoring technique, you will see that the left side of this equation becomes x minus 3 and times x plus 2. That still equals 0. And so we can set each factor equal to 0 and solve for x, which results in x equals 3 and x equals negative 2. And these are our vertical asymptotes. To find the horizontal asymptote, we need to check the degree of the numerator. And since there are no x's in the numerator, we will have a degree of 0. And in the denominator, the highest power of x is 2. So the denominator has a degree of 2. This is what I call bottom heavy, which means that the horizontal asymptote is y equals 0. In order to find the x-intercept, you will set the top equal to 0 and solve for x, except there is no x in the numerator, it is just 5. So when we look at this equation right here, 5 equals 0 doesn't make any sense. In fact, it is a false statement. So when you get a false statement when you're trying to find the x-intercepts, this tells you there are no x-intercepts for this function. In order to find the y-intercept, you just need to evaluate the function at 0. So that gives us 5 over 0 squared minus 0 minus 6, which is 5 over negative 6. And again, since we're finding the y-intercept, this will be our y-coordinate. So negative 5 over 6 with a 0 x-coordinate is the y-intercept for this function. From the previous slide, we have all of our important information, the horizontal and vertical asymptotes and the x and y intercepts. So the first thing I want to do is graph the asymptotes. I've got a horizontal asymptote at y equals 0, and that is right along the x-axis here. Y equals 0. And for this particular graph, we have two vertical asymptotes. So I'm going to graph the first vertical asymptote, x equals 3. Here we go. And the other vertical asymptote at x equals negative 2. So this one over here is x equals 3. This one over here is x equals negative 2. There are no x-intercepts to plot on this graph. However, we do have a y-intercept that happens at negative 5 over 6. And that is right about there. So now we need to graph this. What we need to know is, or what we're trying to figure out is, when we look at the left side of this vertical asymptote, will the graph be above the horizontal asymptote or below the horizontal asymptote? In order for us to figure this out, we need to pick an x value that is to the left of the vertical asymptote. So let's pick negative 5 and evaluate our original function at the x value negative 5. So we will find f of negative 5, which is equal to 5 over negative 5 squared minus negative 5 minus 6. And what that gives us when you use your order of operations and simplify everything down in the denominator is 5 over 24. What that tells us is if we go left 5, right, we input -5, we got back a y value that is 5/24 as our output. So we have an ordered pair. That ordered pair tells us to go left 5, up a little bit, right? Since the y coordinate was a positive number, we're going to go up a little bit, about right there. And since that point is above the horizontal asymptote, then we know that the graph will exist above the horizontal asymptote. So I'm going to draw the graph in here in blue. So that means the graph will get really close to the horizontal asymptote there, and then as we head right toward the vertical asymptote, it'll get higher and higher and higher. It stays above the horizontal asymptote. Our next goal is to figure out where the graph is between these two vertical asymptotes. Will the graph be above the horizontal asymptote or below the horizontal asymptote? And we already have a clue with our y-intercept. The y-intercept is already below the horizontal asymptote, so that means the graph will be below the horizontal asymptote. And for our last section over here, to the right of this vertical asymptote, we need to figure out if it's above the horizontal asymptote or below the horizontal asymptote. And we're going to do something very similar to what we did down here. We need to pick a value that is to the right of this vertical asymptote. And it turns out if you pick your favorite number over there, 4, 5, 6, 7, 8, 9, 10, any of those, that the graph will be above the horizontal asymptote. And this is the graph of f of x equals 5/x² minus x minus 6.